Welcome back to Tales of Chemistry. Today, let's learn something about alkynes. Nomenclature is what we are targeting today. What are alkynes? Alkynes are unsaturated hydrocarbons. They are unsaturated hydrocarbons. Aliphatic meaning open chain hydrocarbons, and they contain a C to C triple bond, carbon to carbon, triple bond has to be present in an alkyne. The general molecular formula for alkyne is CnH2n minus 2. Alkynes are more reactive than alkenes. So, the order of reactivity will be alkane is the least reactive. Alkenes are more reactive than alkanes, and the highly reactive hydrocarbon will be alkyne. The C triple bond C is called acetylenic linkage or acetylenic bond. The homologous series of alkynes are also called acetylene series because the starting member is acetylene and all the other members of the homologous series are referred to as the acetylene series members. Nomenclature of alkynes. The first member itself has two carbon atoms because you need to have carbon to carbon triple bond. So you need a minimum of two carbons. Therefore, the first member's molecular formula is C2H2. The structural formula. Whenever you are writing the structural formula, make sure that you show all the bonds. So, in C2H2, there is a triple bond between carbons. I have represented that. Carbon is tetravalent. So, when the first carbon forms three bonds, it has one more bond to be formed. Now that is satisfied by, or that bond is formed by hydrogen. Similarly, on the second carbon also, three as a triple bond and one bond is formed with hydrogen. That is the structural formula. For this compound, you need to learn the common name, which is acetylene. Common name is acetylene, and IUPAC name of this compound. Look here, you have two carbons. So the root word will be eth. There is a triple bond between the two carbons. Therefore, the primary suffix will be YNE of alkyne, ALKYNE. So the last three letters are taken. IUPAC name is ethine. I've also mentioned the condensed structural formula here. CH, triple bond CH. Moving on to the second example. C3H4, CnH2n minus 2, CnH2n minus 2. N is equal to 3. So this is C3H 2 into 3, that is 6, 6 minus 2, which is nothing but C3H4. Structural formula. Again, I'm repeating, whenever you are writing the structural formula, every bond present in the compound has to be shown. So, three carbons are there. Connect any two carbon, any two neighboring carbon by a triple bond. Then the rest are connected by single bond. And according to the tetravalency of carbon, keep filling up with the hydrogen. So the first carbon here, three bonds are formed. Therefore, I just need one hydrogen. For the second carbon, three bonds are formed on the left side. I need only one more bond. The third carbon, one bond is formed on the left. So the other three valencies are satisfied with hydrogen. When I condense, per carbon, I have to write how many hydrogens are present or what kind of bond is present. So I wrote the first carbon, on that there is a H, so that is represented. First and the second carbon are connected by triple bond. Second and the third carbon are connected by a single bond. On the third carbon, there are three hydrogens, so CH3. That's why this is the condensed molecular formula. IUPAC name of this compound is propyne, and the common name is methyl acetylene, which is not important. Methyl acetylene. This is the common name. You can ignore the common name. Moving on to the third example. C4H6, once again, CnH2n minus 2. So C4H2 into 4 minus 2, that is C4H6. That's how the formula of the third member is C4H6. Now, how do we write the structural formula? I have written all the four carbons. Between the first and the second carbon, I put a triple bond. All the other carbons are connected by a single bond. Now, considering the tetravalency of carbon, the first carbon has formed three bonds. So now it has to form only one bond. The second carbon, it has three on the left side, one on the right side. So I don't have to write any more hydrogens on the middle carbon or on the second carbon. On the third carbon, there is one bond on the left, one on the right, which means I need to write two more hydrogens. For the last carbon, there is one bond onto the left. And here, I have to write three hydrogens. How do I condense and write this? Carbon by carbon, we need to take first carbon, CH, first and second connected by triple bond, second carbon, no hydrogen, second and third connected by a single bond. On the third carbon, there are two hydrogens and single bond, three more hydrogens, CH3. Okay, now how do I name this in the IUPAC system? First of all, number the carbons. When you number the carbons, you need to give the smallest possible number, the lowest possible number to those carbons connected by triple bond. Therefore, now triple bond is between carbon 1 and 2. Out of 1 and 2, again go for the smallest number. That is 1. Triple bond is on the first carbon. How many carbons are there? 4. So bute. What is the, homologous series? Alkyne. So YNE. Where is this YNE present? Or the triple bond present? It's between carbon 1 and 2. Small number out of 1 and 2 is 1. Therefore, IUPAC name of this particular example is bute-1-ine. Moving on to another possibility of writing the structure. 4 carbons are listed, and now I'm putting the triple bond between carbon 2 and carbon 3. Between carbon 2 and carbon 3, I put a triple bond. After this, on the left side, all the other carbons are connected by single bond. So I have one single bond on the left side, one single bond on the right side. Fill it up with hydrogens. First carbon, it has one bond. So I will have to write 3 more hydrogens on it. Second carbon, 4 bonds are formed. I don't have to give any more hydrogen. Third carbon, already 4 bonds are formed. No more hydrogen needed. Last carbon, only one bond is formed. So I will have to write 3 more hydrogens. So that is the situation of another structure which is written with the molecular formula C4H6. How do I condense this? CH3, C triple bond C, single bond CH3. How do I name this? 4 carbons, bute. Numbering. If I number from left to right, the triple bond is between carbon 2 and 3. If I number from right to left, okay, the triple bond is between carbon 2 and 3. That means I can number in any way. I can start from the left side carbon, go on to the right side, or from the right side carbon, I can start numbering. Either way, the triple bond is on the second carbon. Between second and third, out of that, we pick the lowest number. So, bute 2-YNE, bute 2-ine. Now, this bute-1-ine can also be written as 1-butene. Similarly, bute-2-ine can be written as 2-butene. Now, what are they? How are they related? How are they related? Now, these two compounds, bute-1-ine and bute-2-ine, they have the same molecular formula. They have the same molecular formula, but what is different? But the structure is different, or the position of the triple bond is different. So they are isomers, or precisely speaking, they are examples for position isomers. They are examples for position isomers. Same molecular formula, but different structure. In what way is the structure different? Position occupied by the functional group, or the triple bond is different. Therefore, 1-butene and 2-butene are called position isomers. Next example is a compound with the molecular formula C5H 2 into 5, 10 minus 2, that is 8. Let me find out how many different structures are available or possible for this. So first of all, I'm writing all the 5 carbons like this. Connect the first and the second carbon by a triple bond. Rest all are connected by single bond. Start filling with hydrogen. 1 hydrogen here, no hydrogen on the second carbon, 2 hydrogens on the third carbon, 2 hydrogens on the fourth carbon, 3 hydrogens on the last carbon. Count the number of hydrogens: 1, 2, 3, 4, 5, 6, 7, 8. Well, so that is in accordance with C5H8. How do I write the condensed formula? CH, triple bond C, single bond CH2, single bond CH2, single bond CH3. IUPAC name? 5 carbons. Therefore, pent. Functional group YNE. Where is YNE present? It is present between the first and the second carbon. So choose the smallest number. Pent 1-ine. Okay. Do I get a isomer possible? Is there an isomer for pent 1-ine? Let's try. I'm writing all the 5 carbons one after the other, putting the triple bond between carbon 2 and 3, connecting the rest by single bond. On the first carbon, 3 hydrogens. On the second carbon, no hydrogen. Third carbon, no hydrogen. On the fourth carbon, Okay, 1, 2, 3. Fourth carbon, there are 2 hydrogen. Last carbon, there are 3. So count again. 3 plus 2, 5 plus 3, 8. Yes. Now, this is the condensed structure will be CH3, C triple bond C, CH2, CH3. And the name of this is pent 2-ine. Pent 2-ine. Okay. Now, is pent 3-ine possible? Let's find out that also. 3 carbons, sorry, 5 carbons between 3 and 4 triple bond, rest all by single bond. Straight away, I'm writing the condensed structural formula. Okay. Now, if this is the structure, then I will start numbering it from right to left. I'll start numbering it from right to left so that again the triple bond is between 2 and 3, carbon 2 and 3. That means there is no pent 3-ine possible. Okay, pent 3-ine is not possible. Okay, again pent 1-ine and 2-ine are examples for position isomers. Couple of examples more. Next is, suppose I'm giving you a structure like this. Okay. Now, in this, first point is number the carbons. Select the parent chain. Longest possible continuous chain is the parent chain. And now I have selected this as the parent chain. When or after we select the parent chain, we need to number the carbons in such a way that the triple bond gets the lowest possible number. So 1, 2, 3, 4, and 5. Okay, so this is how the numbering takes place. Triple bond is between 2 and 3, so I select number 2. There is a CH3 group. CH3 group is called methyl group. CH3 group is present on the fourth carbon. So, 4-methyl. 4-methyl. Then, in the parent, there are 5 carbons. So, pent. Triple bond is between 2 and 3. So, pent 2. YNE. 4-methyl pent 2-ine. Next example, suppose I'm taking this. Okay, I'm writing one more CH3. Once again, select the longest possible continuous chain. So I did that. Number the carbons in such a way that the triple bond gets the least possible number. So 1, 2, 3, 4, and 5. On the fourth position, I have a methyl group. I have another methyl group. So I have 2 methyl groups. 2 methyl groups. Where are they present? They are both present on the fourth carbon. So 4, comma 4. It is compulsory to write for 2 times this 4. 4, comma 4 hyphen dimethyl. 4, comma 4 dimethyl. Then the parent pent 2-ine. Okay. Now, one last example. Look at this. Longest possible continuous chain has to be selected. I did that. Number the carbons so that the triple bond gets the lowest possible number. Triple bond is between carbon 1 and 2. Okay, triple bond is between carbon 1 and 2. So this will be 3-methyl 3-methyl pent 1-ine. 3-methyl pent 1-ine. If there were two methyl groups, one on the third position and one on the fourth position, then the number naming will be 3,4 dimethyl pent 1-ine. If there were two methyl group both on the third carbon, then 3,3 dimethyl pent 1-ine or 1-pentyne. All right, that's about the nomenclature of alkynes. That's all for today. Thank you.